All right, we're coming up on the end of our unit on two-dimensional and three-dimensional figures. And there's one last hurdle to get over, and that is surface area. Now, surface area, as the name suggests, is regarding two-dimensional area. However, it's referring to the areas of the surfaces of a three-dimensional figure. Now, this can be a little bit difficult to wrap our heads around because when we think about a three-dimensional shape, well, at any given time, you can't see all the surfaces at the same time, especially if it's drawn on a two-dimensional plane. Take this box, for example. At any given time, no matter how I orient the box, you are not going to see all of the surfaces. Instead, the maximum amount of surfaces that you're going to see at any one time is 3. But let's go through all 6 of the surfaces of this box. We, of course, have the top. And then opposite the top, we have the bottom. And then we have what we'll call the front, which is the short side. And opposite that, we've got the back. And then we've got the left side. And we've got the right side. So there are 6 surfaces in all to this box. And in order for us to get the surface area of the entire box, we're going to have to get the areas of all 6 surfaces. Now that sounds like a tall order, but there are some ways in which we can make it a little bit easier to understand and a little bit more digestible to deal with. But it does require us to think a little bit more long-term, a little bit more about our organization than we had to with volume, where we just had to do a bunch of multiplying. So let's start out with some vocabulary that we'll be using. For starters, a surface can be considered the side of a 3D shape. So in the case of our box, the surface is that. We also have the edges of the shape, which connect the surfaces to each other. So they're like the folds in the box. Then we have points, where edges join. And of course, points are pointy. So you can put your finger on the point of a box, and it's a little bit pointy. And that's where edges meet. And of course, surface area, what we call surface area, is the sum of the areas of all the surfaces on the shape, on the figure. Each surface has a calculable area. So we need to calculate all the areas, and then we need to add them all up. That is the basic premise of surface area. So let's put it into action. So to start, how do we find surface area? Well, it may seem like there are a lot of steps, but it's not so bad. The first thing we have to do is analyze the object's surfaces. So depending on the type of object we have, we can determine how many separate surfaces are there. What shapes do these surfaces take? We need that in order to find the area of them. What measurements are required for each surface? And are there any shortcuts, such as duplicate areas? In the case of our box, that is something that's really going to come in handy. And then the second thing we're going to have to do is find the area of each surface on the object. Now, I've pointed out that as an area, you need 2 dimensions in order to find the area. So you only need 2 measurements, technically, in order to find the area of a surface. However, one key difference is that the areas are subjective. Since the areas are subjective, we need to be thinking about finding the 2 dimensions for each area individually, and they may not necessarily line up with the x, y, z dimensions that we're accustomed to using when we're finding volume. And finally, we have to add up the areas of all the surfaces. So here are a few common figures that you're going to find. The rectangular prism, aka our box. Now, fortunately for us, when it comes to a rectangular prism, the side dimensions, all the area dimensions, do line up with the x, y, and z dimensions. So we could have one side be x times y, we could have another side be y times z, and we could have a third side be x times z. And even better is the fact that opposite surfaces are copies of each other. So we really only need to find 3 measurements, and then we just multiply each of them by 2, and then we have all 6. So the way to find it is find the area of x times y and multiply that by 2. Find the area of x times z and multiply that by 2. And find the area of y times z and multiply that by 2. And then you'll have your complete surface area of the box. The next most common thing we're going to have to deal with is a triangular prism. Now, a triangular prism only has 5 sides, but due to the possibly more irregular nature of a triangular prism, it might actually take more measuring to do. So let's see what we've got with a triangular prism. The first thing we have, as the name would suggest, are triangles. We've got 2 of them, and they are copies of each other. The way that you get the area of each triangle is x times y divided by 2. And then we've got 3 rectangular areas. Now, those rectangular areas do all incorporate the z dimension, but the second dimension for each of them is going to be individualized. It's actually going to be each of the 3 lengths of the triangle. So not only do you need the x, y, and z in order to get the areas of the triangular prism, but you're also going to need the side lengths. You're going to need all 3 side lengths of the triangular base in order to complete the project. So that may potentially mean that you need up to 5 separate measurements in order to make this happen. And the last one, I'm going to give a rectangular pyramid as an example of how a pyramid might be done. Now, pyramids are especially special because if you'll notice, the z dimension doesn't show up here at all. And that's for good reason. The z dimension, while imperative for finding the volume of a pyramid, actually doesn't play a role in finding its surface area. Instead, once we find the area of the base, we then have to rely on the side lengths of the base and what we call a slant height to find the remaining surfaces, these vertical surfaces. The slant height is the height of the surface, if we imagine the surface as its own 2-dimensional shape. So you will, if you're trying to find the surface area of a pyramid, be given these slant heights. And it's important to understand that these are what you need in order to find surface area, not the z dimension, not the height of the pyramid. All right, so let's try an example problem. Find the surface area of this rectangular prism. So the first thing to understand is, once again, there are 6 sides to our box, and each of our rectangular measurements is going to be 2 dimensions multiplied together. And we're going to go through all 3 combinations. So we're going to do 8 times 5. We're going to do 7 times 5. And we're going to do 8 times 7. So when we do all that, we get 2 times 8 times 5, that's 80. 2 times 8 times 7, that's 112. 2 times 5 times 7 gets us 70. And when we add up those now 3 measurements, since we doubled each, we have 262 square inches of total surface area. Here we have a triangular prism. Specifically, we have a right triangular prism, which enables us to get away with only 4 measurements instead of 5. So try this one on for size, and then check in with me on the next slide. So the first thing is to establish that we need our x and y dimensions in order to get the area of the triangular base. And we also need the 3 sides of the triangle and the z dimension in order to get the rectangular areas. Now, because this is a right triangle, our x dimension is one of our side lengths, and our y dimension is also one of our side lengths. So they kind of do double duty. So here are our formulas. We've got the two bases, which are x, y divided by 2. And then we've got our three rectangles. We've got triangle side 1 times z, triangle side 2 times z, and triangle side 3 times z. Go ahead and do the calculations. So the area of each base turns out to be 30 square units, but since we have two of them, we end up with 60 square units altogether. And each of our rectangles, our first rectangle is 5 times 11, that gets us 55 square units. Our second rectangle is 12 times 11, that gets us 132 square units. And our third triangle is 13 times 11, which gets us 143 square units. Add up all of those amounts, and we end up with a total of 390 square units of surface area. The last one we're going to do is a pyramid. Now this is a triangular pyramid. It's got a triangular base, and it's also an equilateral triangular pyramid. As you'll notice, the side lengths are each 10. That means that we can assume that the slant heights are also each 12. So with this information, and we are also given the area of the base in this case, so we don't have to calculate it. So with this information, try and get the surface area of this triangular pyramid. So first of all, the number of sides is only 4. We've got the triangular base, and then we've got the 3 side triangles meeting up at the point. Since this is a regular triangle, not only can we assume that the side lengths are the same and the slant heights are the same, but that means that the area of each of those 3 triangular sides is the same. So if we find one, we found them all. So we were given the area of our base, which is 43.3 square meters. And as for each of the side triangles, we know that it's the base length times the slant height. So that would be 10 times 12 divided by 2 because it's a triangle. And then since there are 3 of them, we'll just multiply by 3 on the spot. Each of them is 60 square meters. Altogether, they are 180 square meters. So add the 180 square meters to the base of 43.3, and we end up with 223.3 square meters of total surface area.